Okay, so hi everyone, welcome to this knowledge session. Here we are going to be discussing some more concepts of GCP, means why the GCP is getting more popular, being there are more competitors of GCP in the market. You can say Azure and AWS for the same as well. So we will discuss those concepts in this session. So I am Kuldeepak Gupta, software consultant in Knowledge INC. So before starting the sessions, there are some knowledge certificates which we need to follow, which starts from punctuality. Means we need to join the session 5 minutes prior to the session. Keep your phone on silent. If you have any question, ask me anytime. But after asking the question, avoid the disturbance. And at last, which is the most important one, is your feedback. Make sure to submit your constructive feedback, as it is very helpful for us to make our session more, better. So let's discuss the agenda first. In this session, we will first learn what actually is the GCP, how the GCP came into picture, means a brief introduction to the GCP, then followed by the GCS, which is Google Cloud Storage, in where we will be learning what actually the cloud storage is. We will play in understanding the objects, bucket, storage classes, and the access controls over there as well, means what are they and how they are relatable, if there are any options are available or not. We will discuss the same in GCS. Then we have Big Table and Bigquery, which is the biggest picture of the GCS, where we will be discussing actually what are they, the key features and the use cases, means where we can use them, and if we have some bigger use cases, then we will be discussing them as well. Then we have Google Data Flow. What we'll be learning is that what actually it is, what it does, and again the use cases, as it is very important to learn where we can use it, everything of the GCP if we can. Then we have Airflow as well. In the Airflow, we will be learning means what actually is the Cloud Composer, is the orchestration service which actually collaborates with or integrates with the Apache Airflow, and we know what Apache is. So it will be pretty interesting to learn about the Airflow as well. Then at last but not the least, which is the PubSub. I think most of us has learned about the Kafka. PubSub is pretty easy and most interesting one. So it is the picture, another picture of PubSub. We will learn about it, its degree, and again the use cases as well. So let's start by introducing a very brief introduction to the GCP. So as we know that GCP is all about the cloud. So before going to the GCP, let's have a very short, crisp introduction to the cloud evolution of cloud computing, means how the cloud computing has been evolved from the scratch to the till now, whatever we have. So it starts with distributed system, where we have a multiple number of nodes which are being connected. So it's just a composition of multiple independent system. And the most important thing is it doesn't matter they are connected directly. And the most important purpose is to share the resources and use them very effectively. What does this mean? This, if say for example, if I have a huge process or a number of files to store that, one way is to store in a single place. But what happen if any of the failure or the crashes happen to the system? In that case, we will be losing that data. And the best solution to that is you might have a number of nodes that are being connected together, but not through a common processor, which is again a distributed system. Then after distributed system, we have virtualization, which actually refers to the process of creating or preparing a virtual labor just over the hardware, which allows you to run multiple instances. Say for example, if you have a hardware which consists of which actually have a huge configuration, and you want to do a number of things. So one way is to create a single instance and run, but another way is to create a number of instances which are being connected and run over a single hardware machine. So which is our virtualization, in which we create again a virtual layer. Third one is Web 2.0, which actually is the interface through which the cloud computing services interact with the client. Just the way you have Google Maps, Facebook, Twitter, what actually they do is they just provide you an interface through which you can interact with the client. You don't need to worry about the infrastructure. You just have to do a interface with, means you just have to interact with the cloud computing through any of the interface. Then after Web 2.0, we have service orientation, which actually act as a reference model for cloud computing, which supports a very low cost, flexibility, evolvable applications as well. It consists of two part, means introduce two model here. First one is quality of service, and second one is software as a service. And at last, which is the most interesting one, which is utility computing, which computing model that defines service provisioning techniques for services. For example, you can say the computer services along with the major service such as storage and infrastructure. So how does it help? I will show you later on in the session. So now the question is, if we have AWS, if we have Azure or Alibaba, which is in a very short will available in market, or we have Oracle, then actually what is GCP and why we need GCP? So it is one of the most common and popular cloud service. Google Cloud is a suite for public cloud computing services, which actually is offered by the Google. It runs on the same infrastructure. Let me tell you again, it runs on the same infrastructure that Google uses independently for this. So let me tell you one thing, when it comes to a number of services which you are using from Google, it might be from Google Maps, Google Search, Google YouTube, or any of the thing. They use the same infrastructure on which the GCP operates one. Which make it unique and a bit interesting to use on. So Google Cloud offers services for cloud computing, means compute, storage, networking. When it comes to the data, they provide the big data services for you. You have machine learning and IoT, as well as cloud management, security, and developer tools. So when it comes to preparing and deploying any of the application, you have a number of parameters to look for. It might be the processing power, which are you in need of. It may be your storage. Then you need a good networking libraries. Then you need, what if you have a used data with you and you need to deal with it. Then you need big data power, means you need something that works on big data, ultimately the big data services. Then machine learning, ultimately you need to do some predictions as well. And at last, IoT, which is the most popular thing going on in the market. So Google GCP provides all in a single stuff. GCP provides a wide variety of services for managing and getting value from a data at scale. So this is all about what actually is GCP. Now, why GCP? Due to the higher productivity, owning to quick access to the innovation makes GCP a unique one. Again, less disruption when user adopt new functionality. Google allows quick collaboration as well. It has a number of APIs to integrate with, so it is pretty easier to work with GCP. And last one, Google's economies of scale let customers spend less. Means you don't need to spend more and more when it comes to the cloud computing prices. You just need to look for the scalability and the performance. So GCP economies of scale lets customers spend less. So that's our introduction to the GCP. Now, the first point of the today's session, which is GCS, Google Cloud Storage. So GCS, in GCS, the object storage service in GCP is known to be the cloud storage service, where object storage, everything is stored in the form of object. Bucket, as I'm telling you that everything is stored in the object. Now you cannot store the object at anywhere. You just need to store the objects in a place which is known to be the bucket. So what is bucket? Bucket is just a container for all the objects that would want to place in any cloud storage. It's very popular, flexible, and inexpensive storage service. It can store a large amount of data, and you don't need to worry about what type of data it is. If it is log file, it is an exe file, it is, or any data file, you don't need to worry about it. You just need to save the data. It can store all type of data, and it stores the large object of data using a key value approach, so that you don't need to read the data, means you don't need to find the data again and again from the cloud. So it uses a key value approach, and it has a rich support to access and modify objects using the REST APIs. When it comes to the programming, you need to have some good REST APIs in order to connect, in order to work with the GCP. So GCP provides a rich support for the same. Now, how I told you that what actually is the GCS. Now, how to create the steps which you need to follow while you are working with GCS, and you need to create a file, you need to create a bucket, you need to save a file. So what are the main steps which you need to follow? First one is you need to name your bucket. So these are the 5 steps, and these are the same as you can see on the GCP console as well. So I'm using the same name, which starts from the naming your bucket. So at every moment you have some constraints with you, that so that you cannot take any of the name as in your mind. So there are some constraints while defining your name. First one is your name should be very global, means your name should be unique and it should be global. And one thing which you need to know is it's a permanent name. So if you have named any bucket, you cannot change this, and it should be globally unique. And you don't need to include any of the sensitive information, since if you look into the URL, which I will show in later on in the knowledge, the URL consists of your bucket and every of your data. So if you do put any of the sensitive information in the bucket name, then it will be visible to the user. So don't do this. So this was the first step, where you need to name your bucket. Then second one, where to store your data, means the geographic placement of your data. If you need to store into the Asia or Africa or USA, you need to specify the area where you want to store your data. And this area means that this geographical location will definitely affect your cost, your performance, your availability. So for example, if I am in India, which is in Asia, and if I'm choosing America, where I want to store the data, then it will affect the availability. Since the USA is pretty far from India, then you need to, it might possible there is some problem with the availability. Ultimately, it will increase your cost as well and performance as well, since you need to connect to a huge far data. So make sure whenever you are deploying a replication, you need to properly select the geographical location. And I will show you there are a number of steps to select those things as well. Then when it comes to the area, you have three options with you. Means GCP allows three options which are available for your location type. First one is region, second one is dual region, and third one is multi-region. I will later show in the next slides. I will show you what are they and how could you select them, and what are the basis on the map of which you can select these ones. After selecting the area where you want to store your data, now it's time to select an storage class. Now what does this mean? It means that for which time you want to store the data, and the frequency through which you want to access the data defines the storage class. So it helps in setting the cost for storage, ultimately the retrieval and the operations as well. If say if I want to frequently use the data, and I don't care about that time for which I want to store the data, you have the standard one. Same after standard one, we have nearline, code line, and archive as well. So I will later on in this session, I will show you what does this mean and how can you select this. And the choice should be based on the time period and the access frequency. As I've told you, that it defines for how much time you want to store the data, and the frequency on the behalf of which you want to access those data. So till now we have named our bucket, we have selected the area on which we want to deploy our application or we want to store our data. Then we have selected the storage class as well. Now this time is to select, means how you want to control your data, means how any access or the permissions or grant any permissions which you want to grant or want to revoke from the object. So this is the fourth step, where you define a grain control to every of your object. So you select actually whether or not your bucket enforces public prevention or select access control model. So we have two types of models are here. First one is the fine grain. Second one is the uniform. Uniform is just to provide the uniform access to the end, to all the buckets, to all the data which you do have in your Google Cloud Storage. Second one is the fine grain. Fine grain means, say for example, if you have some bucket and you want to provide some special permissions at different scales at different levels. So in that case, you don't need to use uniform one. You can opt out the fine grain over there. So this is how you can control the access to all the data. And the fifth one is the advanced setting, which is an optional one. Means it's not mandatory, but the first four are mandatory to select. But if you don't want to look into the optional advanced setting, it's an optional, so you can skip that part. But yes, it's a good thing which you can use when it comes to the data protection, data configuration, the protection tool. You can go through the advanced setting as well, which is all about the data encryption methods. So let's discuss the first one, which is the name to your bucket. As I told you that every objects are stored in the buckets. So bucket, which actually is a container which holds every of your objects. It has so your object should have a global unique name. And as I told you that there are some constraints while defining the name. So constraints are at least you have one lowercase letter, one number, one underscore. Constraint is between data can be unbounded, so you don't need to worry about the data means how much data you want to store. It could be anything. So if you have petabytes of data, you can store. So, and since you in any organization we are using if Google GCS services, so you might have a number of projects, so every bucket is associated to the project. So hierarchy could be as follows, that you have a project, you might have a number of projects, and every project you have a number of buckets, and every bucket consists of objects. So this is how the things are being stored in the GCS. Now, the second point which we need to discuss is the unique key, which is used to identify the object, and it should be unique in the bucket. Say, for example, if I have a bucket which is associated to the project, and if I want to store two files with the same name, say, for example, Kuldeepak and Guldeepak Gupta, which is not possible. That will give you an error. The third point which we need to talk about is the maximum object size is 5 TB. I am repeating again. Earlier I told you that you can store a number of things, but every object has a size, and the size of an object must not go beyond the 5 TB. But apart from this, you can store a number of objects as well. So if you have a file of 10 TB or 15 TB, what you need to do is you need to divide it into 3 or 4 parts so that one part cannot exceed 5 TB. So this is all about naming your bucket. Second one is the storage class. As I told you, your data could be anything. There is no such constraint. It might be your media files, archives, application packages and logs. It might be your databases, storage devices, backups. Since you have backups of you with the in order to save your data, protect your data from any failure. So you can store the backup as well. And at last, which will be most important one, which is long-term archives. You can store those as well. And you have means at last what I can say is you have a huge variation in access pattern. It helps in optimizing your cost based on your access needs. So how will you define those needs, the access frequency along with the cost and the type of storage? So we have 4 type of storage classes with us. First one is archive, which means the storage name is archive. The minimum time for which you need to store the data is 365 days. So second one is code line storage. The name should be you can select the option by the code line. The minimum time duration for which you want to store the data is 90 days. Third one is nearline storage, which is known to be the nearline, and you can store the data for at least 30 days. And fourth one, the standard one, and it is it doesn't have any lower bandwidth. Means for the time you want to store data, it could be 1 day, it could be 2 days, it could be an infinite number of times. You don't need to worry about the time duration if you are using the standard one. So this is the time duration. As I told you that while selecting a storage class, there are 2 patterns for which you need to worry about. First one is the time duration, and second one is the frequency for which you are using the storage class. So again, for the archive storage, you use archive storage when you want to access the data very less than in a year. Means you are just accessing your data once a year. In that case, you can select the archive storage. When it comes to the code line, that time means you can read or modify the data at most or maximum in once a quarter. So say for example, if you are using the code line storage, that means you do have some intention to use the data to access the data once in 3 or 4 months. Second one is nearline. For the nearline, the time period of frequency means the frequency of accessibility is once a month. Say for example, if you're selecting the nearline storage, then it is supposed that you want to access your data once a month or twice a month at maximum. But when it comes to the standard one, you can access your data infinitely. Means you can use the data very frequently, and you use this for a very short period of time. And when it comes to the, as I told you that the advanced setting is the most important thing when you learn about is in GCS is you have something that is known to the data encryption, which you use to secure your data, to make a proper protocol so that no one can access your data very easily. So there are 2 types of data encryption. First one is server side, second one is client side. So what is server side? Any encryption which is being done at the cloud side, which is known to be the server side encryption. And the second one is client side, means any of the encryption which you are doing from your end and for which the cloud storage, Google Cloud Storage, is not responsible at all, is known to be the client side encryption. So first we will discuss the server side encryption. We have three types of server side encryptions. First one is the default one, which is managed by the Google. So you just need to select the Google managed server side encryption, and you don't need to worry about the keys which is being used to encrypt or decryption method. You don't need to worry about it. You just need to think that you have selected the Google managed encryption description and you just need to store the data. Second one is CMEK, customer managed encryption key, which is ultimately managed by the customer. In that case, the customer manages the key in the cloud KMS, which is the key management system. You just need to select a key, means you can let the system know that we will be managing the key, and we just I'm just telling you the key, that this is the key, and use this key to store the data, to encrypt the data and then store the data. And third one is again a type of customer supplied one, where cloud doesn't know, not means the cloud do not store the keys. Now what happens is, if for the second one, let me tell you again. Say for example, if I have a data and I want to store first by encrypting and then want to store the data, then what I will do, I will just give a key to the Google Cloud Storage that yes, this is the key which I want to use while saving the data. Means before saving, you just need to encrypt the data. Then in that case, Google will be responsible to use that key again while decrypting the data as well, since you do not use that encrypted data. But when it comes to the customer supplied only, you are responsible to store the key with you. So what happens is, you just in that case, for storing and using it, customer itself is responsible. Say for example, if you want to encrypt the data, you just supply the key. Then while fetching the data, if you want to decrypt the data, you again have to pass the key to the Google Cloud Storage so that they can decrypt as well. So this is the third one, which is the third type of data encryption in the server side and GCS. Second type is client side. Basically, every encryption which we does at our end is known to be the client side encryption, where GCP is not responsible and is not aware of the key being used, and the type means the type of encryption we are using and how we are encrypting the data. Google doesn't aware of it, and they don't need to worry about it. And there is no involvement in the encryption and decryption as well from the Google Cloud Storage when it comes to the client side encryption. So this was all about the Google Cloud Storage. So in a very short, let me conclude all those things. So when it comes to the Google Cloud Storage, some features which it offers is the low latency within a single region, and it provides a high availability, low latency. Okay, so let me tell you one thing as well. I think I forgot to share, which is this thing. When it comes to selecting the location, I think I have not detailed it. So you have three type of options available when it comes to storing the data. First one is region, second one is dual region, third one is multi-region. So when it comes to the region only, which actually is a single region, which provides you a low latency within a single region. For example, if I just want to store the data only in a single region, I will be using a single region, and it provides a high, means a good server response with low latency within a single region only. But if you want to select the dual region, so for example, if I want to select two regions in Asia only, then I can go to the dual region. When you want to use the dual region, if you want the high availability and the low latency across two regions, so this is when this is the time where you need to select the dual region. And if you want to make any your storage very global, means with the highest availability across the largest area, then you can select the multi-region. So this was all about storing the data. So this is all the Google Cloud Storage. Now the biggest picture, which is Big Table and Bigquery. So let's discuss them as well. So Big Table is a fully managed, scalable, NoSQL database service. I'm telling you again that it is a NoSQL, because we might have structured data, unstructured data as well. So it's only for the NoSQL database type. then it is very helpful for large analytical and operational workloads. Say for example, if you have a use data with you and you want to set up an analytics over there, so you can use big table for that purpose. So it's very helpful for large analytics and operational workload. It provides, and the best thing which I can say is, it provides a seamless scalability to match your storage needs with zero downtime if you reconfigure. So for example, if you have used data and you want to scale it, or if you want to reconfigure your storage, then you don't need to worry about the downtime, because it has zero downtime, which make it unique amongst the all cloud providers. Then it can easily connect to services like BigQuery, which I will let you know in the next slide, and even of the Apache ecosystem. So for example, if I talk about the Apache Airflow, which is again a cloud composer, you can easily connect those with Bigtable. Now, the key features of Bigtable: high throughput at low latency. If you want to store the data means if you want to store high amount of data, it is very ideal to store in that case. For cluster resizing, you don't need to worry about the resizing. You can seamlessly scale. You can make it a scale up and down, and even if you have a millions of read and writes per second, it will do scaling at its own. You don't need to worry about the scaling. So what actually it means, you don't need to worry about the downtime as well. Third one is the flexible and automated replication, means to automatically replicate where needed, eventually for the consistency. So for example, if you have put a file, so you don't need to worry about in which region you want to store it. It will do it by itself, means it will automatically replicate according to the need. So say for example, if I have 7 clusters, if I have selected 7 zones to store the data, or if I have selected a number of n only, then you don't need to worry about in which location it want to replicate. The Google Bigtable is pretty smart to store that data or to replicate the data. Fourth one is Hbase migration. Fifth one is Bigtable with data Proc, Spark, and Bigquery. So what does this mean? For the Hbase migration, say for example, if you have some data from in Hbase and if you want to migrate it to the Bigtable allows you to do it very easily and offers to this migration using a number of ways as well. Fifth one, when it comes to the data Proc, Spark data Proc, and Bigquery, it is very helpful. It says to be good that you can use Bigtable, data Proc, and Bigquery togetherly, and it makes a deadly combo when it comes to the data analytics and performing any of the ETL operations over the NoSQL database. So you can use those 3 at a time. So these are the key features of Bigtable. Now, what actually is the use case? If I have a NoSQL database, then I have, apart from the Google one, I have a number of NoSQL databases as well. So what are the use cases? Is any system which is using Bigtable? Yes, I can say yes. So for that purpose, you have your financial system, IoT, and EdTech. And for your information, it is the same database that powers many Google core services such as Google Search, Google Analytics, Google Maps, Gmail, and etc. So you can think how the powerful the Bigtable is, and why we need to use Bigtable only. So it is designed to support applications requiring a massive scalability, and which is intended to be used with petabytes of data. As I told you, the scalability is very high, so you don't need to worry about the flow of data, the rate of data. Just need to think how much data you want to store. That's it. So this is all about the Bigtable. Now the Bigquery. So it is just a data warehouse to power your data-driven innovations. Ultimately, it's a very cost-effective, serverless, and multi-cloud as well. I will show you how multi-cloud means is. Then Bigquery is at the core of Google Unified Data Cloud. It is very, very, very better than any other alternatives of data warehouse. Means I need to say cloud data warehouse. So what are the things what makes it different from the other one? If it is also a type of data warehouse, then how it is different from the Bigtable? So let's discuss them as well. So first, the key features of Bigquery. First one is ML and predictive modeling with Bigquery ML. So what does this mean? As I told you, that Bigquery is just like a data warehouse. So you have a used data with you, and if you want to export some BigQuery ML models for online prediction into the Vertex AI, you can do this, and even you can deploy this on your own server serving layer. Second one is multi-cloud data analysis with BigQuery Omni. So you can use standard SQL and BigQuery familiar interfaces to quickly answer your questions. Say, for example, if you want to execute on the query, in order to fetch or in order to transform or get the data from the data warehouse, so you have a very easy, and it means very easy to use and familiar interface, so that you can get the data, and even you can use a very standard SQL queries for the same as well. Third one is the interactive data analysis with the BigQuery BI engine. Say, for example, now you have data, you have already did some predictions over there, and you just carried out some data. What end of the day, what the organization wants you to do is, if organization wants you to set up an analysis, set up an analytic part over the same. So you need to have something which is the business intelligence engine. So it has interactive data analysis with BigQuery business intelligence engines, which allows the users, which enables the user to analyze large and complex data sets interactively with a sub-second response. What does this mean? That if you, even if you have a huge amount of data with you, and if you are just executing any of the query, you are just working with a number of complex databases, you don't need to worry about the response time. The response time will be sub-second response. Fourth one is geospatial analysis with BigQuery GIS. So BigQuery GIS uniquely combines the serverless architecture of BigQuery with native support of geospatial analysis. So this was all about the big features of BigQuery. Now, what actually is the difference between the BigQuery and Big Table? Since both are ultimately storing a type of data, now what is the difference between these two? So Big Table actually is a NoSQL database, which is a wide column database optimized only for heavy reads and writes. But on the other hand, BigQuery is an enterprise data warehouse for large amount of relational structured data. So this is a difference. But if it's the difference, if is there any use case where we can use BigQuery? Yes, for predictive analysis, or if you want to bring your data into the BigQuery, it is very helpful since it provides you a number of APIs as well. So this was all about what actually the Big Table BigQuery is, the use cases, the difference, and the features of them as well. Now, the third point on which we need to learn about is Google Data Flow. So Google Data Flow is a unified stream and batch data processing, which actually is serverless, fast, and cost effective. It's a fully managed data processing service, streaming data analytics with speed, horizontal scaling of worker resources to maximize the resource utilization. OSS means again open source community driven innovation with Apache Beam SDK. So as I told you that ultimately some of the Google services are integrated or they work together with the Apache services, and we know why the Apache is known for. So it provides you a unified stream to process the stream and the batch data. You don't need to worry about the scalability again. It is fully managed for data processing service. It helps you in streaming the data analytics with speed. And when it comes to the auto scaling, why you need auto scaling? So that you can utilize the maximum part, means you want to maximize the resources when you want to use all the resources at a very high. In that case, you can use Google Flow, which actually even auto means they actually auto scales themselves horizontally, not the vertically. So this is how the Google Flow comes into the picture. Now, the degree of the data flow. Okay, starts with the vertical auto scaling. What does this mean? So we have two type of scaling with us. First one is the vertical, second one is the horizontal. So we have both with us. Yes. So for the vertical one means dynamically adjust the compute capacity allocated to each worker based on the utilization only. So what does the vertical auto scaling means and how does this work? So vertical auto scaling works hand in hand with horizontal scaling to be seamless scale, so that you don't need to worry about the scalability. Second one is the right fitting. Right fitting creates stage specific pools of resources that are optimized for each stage to reduce the resource wastage. So if you have resources, if you have allocated a number of resources, and if you want to make it cost effective, so what you need to do, you need to effectively use the resources, and you don't need to waste the resources. In that case, the right fitting, which is the degree of data flow, will help you out. Third one is the Smart Diagnostic, which is a suite of features that includes three things. First one is the SLO based data pipeline management. Second one is job visualization. Third one is the automatic recommendations to identify tune performing and availability problems. So this is the third thing, which is a degree of data flow. Fourth one is the streaming engine. As I told you, the definition of the data flow is that the streaming engine separates compute from state storage and moves part of pipeline execution out of the virtual machines. So this is the stream engine. Fifth one is the horizontal scaling. As I told you, that it automatically scales horizontally when it comes to utilization of all the resources that you have allocated to it. Sixth one, before moving to the next point, first 3 points which we have, first, which is vertical, auto scaling, right fitting, smart diagnostic, is only means they are new and only available where if you are using the data flow prime, or else if you are using the open source. As I told you, it's an open source, so you are not supposed to use the first three one. If you are a prime member in the data flow, then only are able to use the vertical auto scaling, right fitting, and smart diagnostic. Then we have data flow shuffle, which is the service-based data flow shuffle, which moves the shuffle operations used for grouping and joining the data. Since you have the huge amount of data with you, and if you want to operate some operations over that, so what the operations you might in need of, you want to do grouping, you want to join the data. In that case, you can use the data flow shuffle. Batch pipelines scale seamlessly without any tuning required into the hundreds of terabytes data. So it can tell you, means it's very helpful to let you know that how much scalable it is and how you can work on a number of, means hundred of terabytes data as well. Fifth one, next one is the data flow templates. Before data, yes. Then we have data flow templates as well. Yes. I think shuffle, then SQL. Yes, I think we are getting out of the point. So next we have data flow SQL. Data flow SQL, which actually use it for that purpose. You just need to know about what actually the SQL is, and you just need to have some proper SQL skills in order to drive some data out of anything which you are working on in order to set up or work on the stream or the batch processing. Then you have flexible resources scheduling, which is FlexRS. Now, what does this mean? Data flow FlexRS reduce the batch processing cost by advancing the scheduling technique. So when it comes to, we have two types of processing here again. First one is the stream one, second one is the batch processing. So when it comes to the batch processing, if you want to reduce the cost, what you can do is you can use some advanced scheduling techniques. And this is where the flexible resources scheduling comes in, where you can schedule, that means you can use some advanced techniques in order to drop down the cost of your operations. Next one is the data flow templates. So data flow templates, which actually allows you to easily share your pipelines with team members and across your organization. Now, how it will help you? Say, for example, if you're working for any of the organization, if you have created the template, if you have created the pipelines for the data streaming or batch processing, now if you want to share it with the teammates, sometimes it's pretty hard. So in that case, data flow templates help you. So you can easily share your pipelines with your team members and even across your organization for whom you have granted the permission to share with. Next one is the notebook integration. Iteratively means you can build pipelines from the ground up with Vertex AI notebooks and deploy with the data flow runner. So what does this mean is, if you have built a pipeline even from the scratch. I'm assuming that we have created an application for data analytics purpose, and if we have created it from the scratch and we want to make it up to, and we want to make it bigger. So you can create the data pipeline from scratch with the help of Vertex AI notebooks and deploy with the help of data flow as well. So this is where the notebooks integration comes in. Then comes another picture, which is the real time change data capture, which actually is a synchronization of application data reliably with the minimal latency across heterogeneous data sources. This is the real time. Next one is the inline monitoring, which is the data flow inline monitoring. Lets you directly access job matrices to help with troubleshooting batch and streaming pipelines. Next one is the customer managed encryption keys. As I told you, for the encryption purpose, Google has client side and server side encryption. One of them is CMEK. Next one is the data flow, which is VP service control. So data flow integrations with VP service controls provides additional security for your data processing. So you don't need to worry about the security, which is again one of the most important pillar when it comes to security of data. And the last one is private IPs, which is if you want to turning off the public IPs, which allows you to better secure your data. So for example, if you have anything which is on cloud, so the best way is to access them by using the IP. But if you want to, if you can turn that public IP so that no one can access their data, which actually secures your data, this is the private IPs come to the picture. So this is all about the data flow. Now the Airflow, which is actually the Cloud Composer Airflow, which is a fully managed working orchestration service, which is built on the top of Apache Airflow. Now let me tell you what actually is Apache Airflow is. Apache Airflow is a platform which is created by the community to author, schedule, and monitor workflows. So for example, if I've created the pipeline, now what is the problem with us? We need to check how the pipelines are working. We need to monitor them. We need to schedule them in order to get latest data, or to get the stream data. We need to author them. So this is where the Apache Airflow is. And the Cloud Composer, which is a fully managed orchestration service, it has been built on the top of Apache Airflow. So now you can think how advanced it is. It frees you from the lock-in and easy to use. So if you talk about the lock-in problem from the database, it helps you to get rid of that. So you can freeze yourself out from the lock-in and easy to use. Again, it is a service which is used to author, schedule, and monitor pipelines that shown across the hybrid and multi-cloud environment. So, for example, if you have if you're not using a single cloud, if you are using a hybrid or number of clouds, which is going to be the multi-cloud, and if you want to schedule, monitor the pipelines, you can use the Cloud Composer, which is again which is being built on the top of Apache Airflow. The key features is you can use it on the multi-cloud. As I told you that you can author a number of clouds as well. It is open source. It has been built on the top of Apache Airflow, so it is also an open source. Apart from the multi-cloud, as I told you, if you are using the hybrid, so it orchestrates the workflow that across between one premises and the public cloud as well. So when it comes to the hybrid, it is very useful. Next one is the integrated. So you can integrate it with the Bigquery, Data Flow, Data Proc, Data Store, Cloud Storage, PubSub, which I will be discussing in a very short, and the AI platform as well. Next, when it comes to the programming language, I think everyone knows Python, how the Python is very useful. So you can dynamically author and schedule every of your workflows with the help of Python programming. So you can use those API as well. When it comes to the reliability, it increases the reliability of your workflows through easy to use charts. It is fully managed, means which allows you to only focus on how the authoring, the scheduling, and monitoring the workflow should be. You don't need to worry about the underlying infrastructure, the hardware which you are using. So you don't need to worry about even the security as well. So it's fully managed. And at last, which is important one again, which is a network and security. So during the environment creation, it allows you and provides a number of configuration options which you can use in order to create a good networking options and to create the securities as well. So the last one is PubSub.
Deepak, I am really sorry to disturb in between, but it's already 5, Kuldeepak. So if we can wrap up the session quickly, that would be really great.
Okay, Bharti, just within 5 minutes I will be wrapping it up.
Sure.
Okay, thanks. So for the Google PubSub, it's a fully managed working orchestration. So let's discuss the key features directly. It will help you in learning what the Google PubSub is. So just like we have Kafka, we have the Google PubSub as well. So we even for the Kafka, if you want to look about the alternative, you can use Google PubSub Lite, but for the purpose of Google PubSub, it is very helpful while you are ingesting a large data sets. So the key features, which starts from the Google Cloud Native integrations, which integrates multiple services just as CS, Gmail updates events. When it comes to the seek and replay, you can rewind your backlog to any of the point in time or the snapshots or the backups, enhancing the ability to reprocess the message if you want, if you have a process, and if you want to seek around it, if you want to read that, if you want to reprocess that message, PubSub helps you in doing the same. Then we have third party and the OSS integration, which provides the integration with Splunk and Datadog for logs along with the stream and Informatica. Informatica and stream again an ETL tool which you can use for the data integrations as well. Then we have dead letter topics which enables the subscriber applications processing and put aside the offline examination. For the filtering purpose, yes, you can filter the message based upon the attributes, even upon the time stamp, the last message size, the earliest offset. So it actually leads in reduction in volume delivery as well. Then at least one delivery. What it means is it is synchronous. I think everyone knows what actually the synchronous means, which actually is at least once delivery. Then cross-zone message replication. Then we have exactly one processing. Since we have at least one delivery, that leads to the exactly one processing, which means data flow support reliable, expressive, exactly once processing of pub/sub streams. Then we have open. Open means it has some open APIs which you can integrate with any of your programming language, just like Java. We have Python, C++, C#, or any of that. I believe Ruby as well. So what it means, it has open APIs and client libraries, so you can work upon directly or you can work hybridly deployment, so it supports that thing. Then we have no provisioning and auto everything. Just by setting on your quota, publish and consume, just don't worry about much of your data, just need to setting up the quota, means how the pub/sub should work, the publisher and the consumer. That's all for the pub/sub means for the first time if you are using the pub/sub. And last, which is the compliance and security. It offers a fine-grained access controls and end-to-end encryption for the data. So this was all about the pub/sub. So in this session, we have just discovered the main concept for which the GCP is very known for in the market. So these are some basic, means these are some concepts which for on the behalf of which you can select the GCP on the top of other ones, which is for Azure or your AWS as well. So this was all your session, and I'm very open. If you do have any of your doubt, I will try my best to answer you.